Okay, we're talking maintenance today, maintenance of your PA46, and I've got the right guy to help. Kenneth Hale got you in the office today, talking about in the Malibu Guru office, that is, talking about maintenance items today. And we got a whole bunch of good questions that have been given by listeners, but a lot, we kind of grouped them together in maintenance, and I'm glad you're here to help us talk about it.
Glad to be here. I'm glad to help.
Hey, but before we get any further, as of July, we've been in business 1 year doing maintenance. It's now October. So we're about a year and a quarter into this. Give me a brief. Give everybody else a brief. How's it going so far?
It's been really busy, and the community's been a blessing to us. It was a really warm reception, and we hit the ground running, and we've been adding staff members and increasing hangar size pretty much as fast as airplanes can show up. So,
right.
But it's been a real blessing.
We've got 150 by a 70-foot hangar, and we're about to add another hangar coming up pretty soon. but your number one problem that I would say, if we had to tell me, what's your number one problem that you've got today?
It's still manpower.
Just finding good people.
Finding good people, not so much finding good people, but getting the good people up to speed to do the quality of work that we really want to do. So we're still not as fast as we'd like to be, but we're still holding that quality standard. And that's far more important to us than, just throwing people at the problem.
Yeah, manpower is such an important thing. You got to get the right people. We have a saying all the time that we don't want any donkeys. We want nothing but thoroughbreds. And to build a team of thoroughbreds, you can't do it overnight.
No,
it takes a while.
Yeah, it's definitely handpicking personalities to gel with our other personalities. It's a very cohesive team down there. So
yeah,
it's a close group, and we want to make sure we've got the right people.
It's so interesting to me because when you talk about manpower being the biggest problem, it's not that it's hard dealing with the people we've got. They're great. It's so interesting that I'll go down there, everybody's friendly and happy and getting work done and doing good stuff. It's just we're in Lufkin, Texas. It's not a regional. It is, I guess, to say it's a regional.
It's not an aviation destination, if you will, like Houston or Dallas or Austin or any of the major airline hubs. So it's definitely not at the top of your average mechanic's list to live here.
Right.
But we make it worthwhile.
But we make it worthwhile. So yeah, if you know of anybody looking for a job, we're definitely hiring. We're in the hiring mode for sure. Number 2 problem, let me guess, hangar space.
Yeah, hangar space is the next one. Yeah. You kind of have to grow one with the other because as you grow your team, you need more spots to park airplanes for those team members. So it's kind of a fine balance of having just enough hangar for just enough people.
Right. We've got you in what I consider to be a really crappy office, if that's the right way to say it.
It's a temporary living condition.
It's a temporary office. Yeah, we've got a really nice hangar, but a temporary office. And that it's literally a trailer that's on wheels, but it's just temporary while we build the new one. We're about to have new offices soon. It won't be long. We're going to dig the dirt and begin that project. We're also building another hangar with a office onto that. We're going to almost double in size in the next year. The demand has been good. For somebody that wants to book an annual, it's never too early, correct?
No, it is never too early. I always try to tell people to at least book 2 months out. It is more convenient, not just for us, but for any maintenance guy out there. We're all pretty booked. We're all pretty busy. So the more you can think ahead of what your schedule is going to look like and get your aircraft scheduled in, definitely do so.
One of the things that we like to tell people is that if you want your annual done with us, we'll come get your airplane and bring it back here. And we like doing that because there's a test flight involved. But a lot of people, there's a problem with moving their airplane here, and then they got to airline home. And we have pilots that'll do that for you. We just want people to know that we have resources to be able to get your airplane here. We don't overcharge in that respect because number one, our pilots get a chance to fly your airplane and really squawk it out on the way to the maintenance event. And also they get to fly it on the way home to make sure that everything's right. And so it's a beautiful thing. So that logistical piece is sometimes a challenge. We want people to know that we can get your airplane here.
Yeah, we don't want it to be a logistics issue.
We don't want it. It's Lufkin, Texas is maybe not the easiest place to get to in that respect, but we're an hour and a half away from the Houston Intercontinental Airport. So it's not far. It's not hard. And matter of fact, we have a Bonanza and a Cessna 182 that we'll use to move people around when we can. So we just want the logistics of that annual inspection to be easier. And that's a good thing as far as that's concerned. Okay, we got a bunch of questions we want to talk about. The first one's kind of near and dear to my heart. Talk about a static leak. We had a jet prop that we know of recently that took off, and whenever it took off, basically the instrumentation for the pedostatic instrumentation began to go haywire. Really, what ended up happening was the airspeed started to go down. It really scared the pilot. It really did. At the end of the whole thing, pilot got on the ground, which is great, and turned the airplane over and to maintenance. And how does a static leak happen?
A lot of the time, it's either because the lines are old. It's definitely more common in the pre-90s airplanes right now, and 10 years from now, I'll be saying 2000s. But, pre-90s PA46s have been the primary problem children in that area. It's just because the static lines are made out of nylon, and nylon is definitely an ageable material, and as it ages, it dry rots and cracks and breaks.
And then
you end up with a leak in a pressure vessel.
Right. And there's your problem. It's not that it's a leak outside the pressure vessel, because the static lines in a PA46 go from the tail of the airplane inside the pressure vessel up to the front of the airplane where all the action's happening. And if there's a leak along one of those nylon lines, now the pressurized air from the pressure vessel is going into that static leak. And I'm telling you right now, it can be a little scary.
It can definitely cause havoc because it's driving the indications in unusual directions, depending on if you have a PDOT leak or a static leak. If you're pressurizing the PDOT system with cabin pressurized air, it's going to drive the airspeed up, which can be particularly dangerous because that a lot of the time results in the pilot pulling the power back, and then you find yourself in a stalling configuration because you don't have the power you need to stay in the air. Static leaks do the opposite because your static system's tied into your airspeed. So as you pressurize the static system, it will drive your altitude down, but since airspeed references static pressure, it will also drive your airspeed down. So it will look like you're in a descent at a very slow speed.
Right. And it can be very disconcerting because you don't really know what the problem is. Like this pilot was very fearful that they had an engine problem because the engine wasn't developing enough power to produce the performance that they were expecting. And now they're like, what's going on? And it ended up being a big, gigantic mess when it was nothing more than a static leak. Now, static leak's not that easy to fix in the sense that we're going to have to find the leak, rip out a bunch of interior, aren't we?
You pretty much got the entire interior out of the airplane. Yep. Yeah, because it runs in the sidewalls and floor from the front to the back.
Yep. It's all that's coming back out. I will tell you, if you ever suspect a static leak in a PA46, I've seen that it probably happened 5 times over the last 10 years. And meaning I've heard of it, or I had a client that had it. I've had it twice that I personally have noticed. And if you suspect a static leak, there's an easy way to figure it out. And that is jump in your aircraft, close the door, go make a pressure vessel, and hit your vent defog blower. Now, what that's going to do is it's just going to barely pressurize the airframe. But if you hit that vent defog blower and you see any pedostatic instrumentation move at all, any, you have a static leak.
Absolutely.
And it's a fail-safe. It's almost, that's probably the wrong way to say it because
it's an excellent way to check.
It's an excellent way to show that you have a pedostatic leak or static leak in the airplane because it will instantly barely pressurize the airplane. That pressurized air now goes into the static leak, goes to the instrumentation, and shows you what you've got. And if this is the case, you got yourself a mess as far as that's concerned. The best thing you can do, depressurize the airplane. get down below 10,000 and literally cabin dump the airplane, and now you're inside your airplane is going to be reasonably equitable to the outside. There's probably going to be a minor lag, but I'm getting rid of pressurization altogether. If I know I'm in flight, have a static leak, you're gonna know it. I've also seen an airplane that got a static leak in flight where it happened while we were in flight. In other words, just the vibrations, and our airplane was on autopilot when all of a sudden literally the autopilot's flying the altitude that it's indicated, and all of a sudden that altimeter just starts winding, and it just pushes the airplane over, and
the autopilot chased it.
Autopilot's chasing it. It's doing what you told it to do, which is follow the altimeter, which is now. And this is why we have humans in the airplane, because there are things that can happen in the airplane where the only thing you can do, shut off the autopilot and fly the dadgum airplane.
Fly the plane.
And I'll say one more from a pilot's perspective: know your power settings. If you're on an approach where gears down, flaps are at 20, and you're at 30 or 22 inches in your Mirage, well, that's going to get you about 115 knots. And that's why we know power settings in the airplane, so that you can go to those power. You could literally, I'm not advocating it, but you could cover up your airspeed indicator in an airplane. If it had failed, if you had icing in flight or had something that caused that airspeed indicator to fail, you ought to be able to fly an approach, because you know your power setting and your configurations because you've done it so many times.
Right. It's an excellent reference tool.
It's an excellent reference. Let's talk about oil consumption. We've had a lot of talk about oil consumption in the past, but I want to talk about it some more because it's important to a Lycoming. I guess it's important to a Continental pilot too, but let's talk about Lycoming.
It's a much larger conversation with the Lycoming fleet. The Continentals don't typically consume oil. It's a lot more unusual. The Lycomings, though, most of the time is due to oil control ring failure. That's pretty common. We changed 3 cylinders this year for that very reason. One cylinder just goes to drinking oil.
In the oil control ring, you have 2 compression rings, and then on the third down ring is going to be your oil control ring.
Correct.
And what that's doing is shoving pressure against the cylinder wall, and allowing oil to not flow to the compression area, and keeping compression from going into the oil area.
Correct. It's a fine line between just enough oil to maintain lubrication of your top 2 compression rings, but not so much that you're consuming excess oil. And that's the whole job of the oil control ring, is to scrub excess oil off of the walls. It's kind of a special ring. It's got some grooves cut in it and some holes, and as it scrapes the oil off, it pushes it through the piston back into the case.
Yep. And if it breaks, because basically that oil control ring will move around as the piston's going, piston's going up and down, but it will move around and kind of not get too hot in one area. It'll kind of have flow to move around as it does. But if it sticks because you got a bunch of gunk because you're running rich all the time, and that oil control ring freezes in place, now it's going to get a hot spot. It's going to crack, break at that hot spot. Now you end up with 2 parts of an oil control ring with no pressure exerting against the sidewalls, and oil is now going to go through the oil control ring into the combustion area, burning the oil and eventually going out the exhaust. Consequently, it's going to allow combustion air to go by that oil ring into the crankcase.
Yep, it will look just like a diesel whenever you pull the dipstick.
That's right.
Whether the oil's an hour old or 20 hours old, every time you pull the dipstick out of one that's got oil control ring problems, it's going to look like a diesel pickup truck. It's just a lot of combustion byproducts making its way past the rings.
That's right.
But yeah, normally the first indication, definitely keep a pilot log, definitely track your oil consumption. Whenever you're adding oil, track the number of hours between quarts. It's particularly important because there are some things that we as mechanics can do to solve stuck rings, but once they're broken, there's nothing we can do to solve a broken one except for replace the ring set or cylinder assembly, depending on the condition of the cylinder at that point. So if you can keep an eye on oil consumption between flights, and you can kind of track how many quarts or how many hours you're flying between adding a quart, and you get a feel for what your engine does normally. And if you start to see a decline, so if you're using a quart every 10 hours and then you sneak down to a quart every 7 pretty quick, well, you should definitely call your mechanic and say, hey, I had a trend change, just like in a turbine or anything else. I had a trend change, a trend shift that says, I'm using more oil. Well, we should look at that. And as I said, there's some things that you can do afterwards to unstick the rings on the piston without having to remove the cylinder.
Right. Some things that are going to happen in a maintenance shop.
Correct.
Yeah, that's exactly right. I tell Lycoming pilots that you need to check your oil frequently. Usually you want to do it like an hour after your flight at least, because all the oil then goes down into the oil drain. Where you can get a good accurate reading. And I would say good accurate reading. It's just it's a small deviation.
Right.
You really need to learn to read that oil dipstick. But they're looking for two things. I'm looking for oil that turns black quickly. If it turns black quickly, that's combustion getting into your oil, and there's only one way it's going to get there. So it's telling you exhaust gases are getting into your oil reservoir and causing that oil to turn black quickly. The other one is consumption.
Right.
And consumption that goes, I'm gonna guess you would, how many quarts, how many hours per, like if you burn 2 hours and you burn a quart, do we need to do something?
Yeah, that is the limit. So the Lycoming, Lycoming has a service instruction for calculating oil consumption. It's really geared towards new engines, but it's across the board for all of the engines. And it's a formula that if you have X amount of cubic inches and X amount of horsepower and X amount of oil capacity, then you're allowed to use X amount of quarts of oil and X amount of hours. On the AE2A that's in the Lycoming, that comes out to 1 quart for 2 hours of flight.
Okay.
Now, is it a safety of flight concern? Yes and no. I've had people ask me, well, am I going to see that in the cockpit? And the answer is no. I've seen a Lycoming that was drinking a quart an hour, one that was drinking 2 quarts an hour. And besides the fact it had, a pitch black exhaust trail on one side, there was no other indication that the engine was operating abnormally. It passed mag checks, it made full power, and it operated otherwise perfectly fine. It just consumed a lot of oil. And
which can be a problem on a long flight. You have a 4-hour flight from Texas to South Carolina, and you're burning a quart an hour. You can pump most of your oil, if not all your oil, overboard. And now you do have a safety of flight issue.
Absolutely.
And bottom line is, and we have had this happen in our community. We have had aircraft that have pumped all their oil overboard. Turbochargers then fail, engine failed. It's a disaster. You end up with an engine failure because you didn't take this seriously. And so the point I'm making is, if you need to keep your oil level high and get it to a maintenance shop.
Yeah. Basically, once you have identified that there is an issue, the next flight that needs to be happen is direct to a maintenance facility to have it addressed.
You talked also about you're going to have a black oil going down one side. And it's fairly obvious, but one of the best pre-flight items you've got as a piston PA46 or a piston, any piston, is to lay on the ground and look at your belly and the belly of the airplane. Because if you just narrow down, if you got an oil streak down one side, you just narrowed it down to 3 cylinders that it's coming out of the right side. It's one of those cylinders, or the left, it's one of those. And there's something different between the two. Meaning, if one, the old kid song, one of these things is not like the other. I'm not going to sing the song, but one of these things is not like the other. One of these things just doesn't belong. Anyway, you know the song. 2 things don't look right. Something's not right. And if you got 2 streaks or 1 streak going down the belly, it's telling you something about this.
You do have a breather on one of the tailpipes where overboard crankcase ventilation is burned off. So you'll end up with a slightly darker hue on one side or the other. But if it looks like a diesel truck exhaust was running on the belly of the airplane, then definitely have a problem. And it's the belly of an airplane tells you a lot. Keep it clean. It's a really good litmus test of what's going on.
My next statement was keep it clean, and get up under, or have some airport guy, trade hours or something, but have somebody get up under there and clean the belly of the airplane, because when it's clean, you can actually see when something.
Exactly. It's a good barometer of what's going on under the cowling.
Yeah, exactly. Oil consumption in a Lycoming, super important. Like a good Lycoming pilot's going to know consumption, going to know the color, going to know how often they're going to really understand oil in a Lycoming engine. Or should, if they're going to do it right.
Correct.
Yeah. All right. We got a cool guy named Marcus Springman. He was probably in one of the early podcasts. He's from Canada. This is a super cool guy. He's just been a real good advocate for us, and advocate for our community, and flies a Continental Malibu. And he basically talks to us, sent us a long email that talked to us about the oil separator. And, one of the other things that came up is we had a Continental Malibu that was flying from Canada on its way over to Europe, but didn't quite make it to Greenland before the engine failed. And there was wonderful video of this pilot. They just had some really good video, because number one, it happened at high altitude and they had time, and they actually videoed the pilot as he's coming down.
It's just wild.
It was crazy. To be brutally honest, I thought the guy did a great job. I mean, you have an engine failure over the North Atlantic and you get to tell the story. You did it right. And this pilot did it right. I was very, very proud of this pilot to be able to do this. But one of the problems is we don't know what caused the engine failure, because that airplane's at the bottom of the ocean in the Davis Strait, and there's no one going to get that airplane.
No, it's a little deep, I think.
Yeah. So one of the questions is we think that one of the discussions is oil starvation, in that, could he have had an oil leak that caused things to happen? Marcus has seen a problem with the oil, with the oil separator on the Continental. And you've seen some pictures that he's shown us. And what I wanted to talk with you is, how does this work? What happens with this? Why was this something that we need to consider?
So I think age of aircraft plays a big part in it. So we're finally reaching the age on some of these airframes, and time and service on some of these airframes, that some of the parts installed on them, even though they weren't directly called out to be inspected, probably we're at the point now where we should be inspecting them, not because there is an inherent issue with the part itself, but because of the amount of hours that are on the components, and you get sludge buildup and grime and dirt.
Meaning this is not on the maintenance manual that you need to be checking this at every oil change and blah, blah, blah. That's even an annual inspection. Are you required to check the oil separator?
No.
Okay. So this is something that, and Marcus sent us some pictures, which we're going to show. You can watch, if you're listening to this audibly, you can watch the YouTube version of this and see some of the pictures of sludge that built up inside here. Looks pretty hairy to me.
Yeah. It was a really good find on his part, because the way that the problem presented itself was somewhat non-standard. To be brutally honest, if you had called me and asked, I would have said, well, it sounds like we have a ring issue on a cylinder. And, it would have been an easy spot check, pull plugs out and look at spark plugs and go from there. But the fact that it was a clogged air oil separator is interesting. Like I said, it's a little on the non-standard side. That is what the issue was. But an incredibly good find, though. Good find
on Marcus's part. And again, Marcus has owned a Continental Malibu for a long time, so he's a veteran when it comes to this type of thing. But let's talk. What does the oil separator do?
So the air oil separator is responsible for separating air from oil. So in a piston engine, we have a very large rotating assembly called a crankshaft, and it has connecting rods and pistons and gears, and all of that, as it's slinging around in the crankcase, is picking up oil and turning it into a fine mist. Fine mist is not our friend, though, because we have to get rid of excess pressure in the crankcase. We operate turbocharged engines. Well, turbocharged engines normally have positive crankcase pressure. So how we handle that is we take the excess crankcase pressure and we run it through the air oil separator to spin the oil out of the air. So that way, whenever the breather literally spin it, centrifugally separates the oil from the air.
And slings the oil to the outside of the can, basically. And then the oil sticks to the outside of the can, then eventually falls down via gravity?
Yep. And it goes into a drain and it returns back to the engine. And the air goes over out of the can and into the left-hand tailpipe. So that way, any remaining oil can be burned off. Gotcha.
Is this Lycoming's, Continentals? Is this
in the PA46 fleet? It's both aircraft, both the Malibu and the Mirage.
Okay, so this is something to start. It's something to start looking at. We've got a couple of Continentals inside there. I know you're going to check it out today.
Yes. Yeah, it's like I said, it's definitely an airframe age related thing. As airplanes age, there are parts that we never ever really have to touch because they're perfect, and there's nothing that really drives us to go look at it because they never have a problem. Why would you? But as airplanes age, there are definitely components that fall out and need, more repetitive inspections.
Right. I understand completely. So something good to look at. And next time you get an oil change, have your
have them pull the drain line off of the air oil separator and take a peek and make sure it's not clogged.
And if it's clogged, let us know. Let us know what you find out. I'll be interested to see if the community of Continental engine airframes out there see a problem with this. If it is, I'd love to hear about it. And I know you would too. And we'll definitely sound the alarm and let people know. When we talk about Continentals, the other one I'll talk about is a gear-driven alternator. We had one happen recently. You've got two alternators on a Continental engine. One of them is belt-driven. One of them is gear-driven. And if you have a gear-driven alternator that has troubles, you can have big troubles.
Yeah, they can get... They can range in levels of interesting in the way that they fail. I've actually seen gear-driven alternators fail in a couple of different ways. The first one, this is the more common one, the alternator is comprised of three pieces. You have the nose housing, the stator assembly, and the tail housing. And there's tie bolts that hold the three together. And over time, even though they're safety wired, they can back themselves out of the case. And eventually what happens is you have nothing holding the halves together anymore. The alternator drops onto the rotating component and it grabs a hold of the wires and just wraps the wire bundle around the alternator. Yep.
It eats itself.
The second mode of failure, this one's a little bit less common, is the shear coupling. So you have a gear, then you have the alternator, and the fear is that if the alternator shaft locks up, you don't want to shear the teeth off on the cam gear in the engine. So what they designed was a rubber shear coupling that goes between the gear and the alternator itself. So if either component locks up, the rubber inside shears and it protects the more expensive component being the engine.
I've heard it called a shear shaft. Is that right?
Yeah, it could be called that too.
Okay. Same type of, like I've seen a shear shaft where it narrows in diameter and that's where it's going to break.
Yep.
But this one's a rubber, which is where it's going to give.
Correct.
Okay.
And it's just like everything else. It's a piece of rubber living in, 190 degree oil all of its life for however long it's been installed on the plane. So they definitely have a shelf life, although not spoken, but they do have a finite life. It's a piece of rubber submerged in oil.
Right. So, okay. But when it happens with a geared engine, what happens? Meaning you have a geared alternator. The idea behind it is if if the shaft were to not shear and the gears were to break, now you can end up with metal going through your engine.
Correct. Yeah, and I did see another one. There are certain configurations of Continentals with an old style cam gear. That's I think it's a double spline. I don't remember. I have pictures. But the splines wear over time and the gear can walk. So there's really nothing holding the gear in time anymore, and eventually those do fail too. Most of those engines are well out of the fleet, though. I think there may be only a handful of those running around at this point. But yeah, I mean, if either the gear that's on the alternator or the cam gear itself fails, the driving or the driven gear, it can definitely make a mess.
And can send metal shavings and things through the engine that then can get into other areas, which then I mean, I know of 2 engines that have been virtually destroyed because of this. And so this is one of those if you get an alternator problem on a Continental engine, you need to know, is it my gear driven or is it my belt driven? If it's your belt driven, well, you're probably okay, because if it fails, it's outside the engine and there's no problem.
Right.
But you should know which one's which, and you shouldn't be able to respond to that. You get a gear driven alternator light in your cockpit, that's probably a really good reason to go land the aircraft and figure out what's going on.
Super easy way to tell is pick the nearest airport that's suitable, land, get out of the plane, bring your flashlight with you, look in the back of the alternator at the cooling fan, pull the prop through. You should be able to see the cooling fan spin. You can't see the cooling fan spinning, there's bigger problems.
There's bigger problems to be had. And those bigger problems literally can take an engine out.
Yes.
It can literally cause huge and gigantic problems, for sure.
Yeah, the alternator is definitely the cheaper part. So if you have an alternator failure, definitely you want to look into that before you just keep flying.
You know, a lot of people go for a Continental Malibu because it's just so efficient. 15.5 gallons an hour to do what a Lycoming does at 21 or 22. Lycoming has a very expensive, it's up to $145,000 for a factory reman, for a Lycoming today. Cheaper for a Continental. To operate a Continental engine today, Continental Malibu is certainly cheaper than a Lycoming, except for the fact that you can have stuff like this occur, that airplane, can have way fewer hours and all of a sudden the whole engine's destroyed because of an alternator. There's things that can happen. Would you shy away from a Continental airplane today?
No.
Okay.
No, I'm still a fan of them.
Yeah. I think if between a Continental or a Lycoming, I'm going with a Continental just because I'm a believer in Lena Peak. The Continental is designed for Lena Peak, and you end up with it's mated perfectly to the airframe, and I just think the Continental is just a good one, but you better know it.
You better know it. They have their nuances, and you just have to be well versed in your airplane. It's no different than any other aircraft. Every single one's got its little quirks that you have to know about, and as a trained pilot, you just have to be watching for. And if you see one crop up, you just have to know how to deal with it. And besides that, I mean, it's no different than any other piece of mechanical equipment. Every piece has its own flaws, so you can look at it the same way. The Mirage has its own quirks about it as well. So it's really trade-offs. It really just depends on what's your mission and what would you like to be trained on.
Right. Okay. I'm in complete agreement as far as that's concerned. Let's talk about upgrades to a PA46 related to maintenance. So if you had somebody that owns a PA46, and we'll go piston or turbine, however you want to go with that. If somebody wants to spend some money to make the maintenance guy smile, what are you recommending that they do?
For the pistons, the biggest mod I can possibly recommend is Malibu Aerospace's cooling mod. It makes such a big difference to the cylinders that don't get enough air, cooling air, and in an air-cooled engine, air is life. So anything you can do to give those cylinders the air they need so they run cool, especially if you're running lean of peak or especially down here in the south where we have lots of days over 90, 95 degrees, high density altitude. Yeah. Anything you can do to get that engine more air absolutely is going to be a go-to for me.
Yeah. Okay. M5 cooling mod. Anything else?
The other one for the turbine operators, Meridian's M600s, the RG4153 STC, the larger capacity battery. It's a no-brainer. If you're coming up on battery replacement, don't even buy the old school one. Just buy the STC.
And they're expensive.
They are. They're
All
painfully
batteries.
expensive. The RG41 is expensive. The 4153 is expensive. There's honestly not a huge price difference between the two. So there's really no driving point to even buy the old one anymore.
And we're seeing engines that their start temperatures will be cooler by 80 degrees.
Yep.
I mean, I've seen engines that historically started in the 800s, where you're sort of got your hand right on the condition lever, sort of watching it. Then all of a sudden it's topping out at 750. And
the other one that some people have looked at as a detractor is it adds about, on average, on each aircraft we've done, about 9 pounds to the nose of the airplane. Some people think that's a detractor. I've had other pilots think it's great because it shifts the CG forward a little bit more, and every little bit we get helps. So,
yeah. Any other modifications that you can think of that you would that you just smile whenever you see it, or you think somebody's wise to do?
Not that I'm aware of. On Meridians and Mirages and Malibus, battery minders. I mean, that's super easy.
Yeah. Yes, it's super easy to do and does impact the life of that battery.
Yeah. Anything you can do to extend the life of that very expensive battery is money well spent.
Yeah. We talked a little bit earlier. We just glancingly talked about Lena Peak earlier because we talked about Continental engines and how they're just specifically designed for Lena Peak. And that's specific. If you look at the POH, it says fly the airplane Lena Peak. You end up with a lot of Lycoming owners that want cooler engines. And so I want to, I guess, pontificate just a minute on Lena Peak, and you jump in when you feel like you can or should. But Lena Peak and a Lycoming, I have discovered that it doesn't work very good. I think it works about 10% of Lycoming airplanes. And when it does, it is right on the hairy edge of, in other words, you get all 6 cylinders that will be Lena Peak, and it has instrumentation for it that allows it to be Lena Peak, meaning where you can monitor the engine. But most Lycomings just don't run well Lena Peak. And the reason why is dwell time. In other words, the way where the valves open and close, it just doesn't give much time for that fuel to burn Lena Peak and doesn't develop very much power. Continental specifically designed for Lena Peak. And so I've seen Lycoming engines run Lena Peak, but instead of doing 200 knots at 20,000 feet, they're doing 175.
Yeah, it's a pretty big sacrifice.
It's just a huge, you lost this huge amount of power to go Lena Peak. And it's almost like there's people that are Lena Peak. They're just so, it's like religion or politics. They're just so passionate about Lena Peak that you end up in this place of, really, you're going to run this thing you're going to lose that 25 knots because you're Lena Peak. And then I've seen I went to fly with a Lycoming pilot here not long ago, and he said, yeah, my standard go-to power setting is 34 inches of manifold pressure, Lena Peak at 2,400 RPM. And it was just like, no, it's you're trying to get something to do something. You're trying to get an engine to do something that's really not designed to do it. And you end up trying so hard to do it that you end up with these weird parameters that you can almost hurt an engine whenever you're trying to do. You're trying to get it to do something it's just really not designed to do.
Yeah, that's really what it comes down to. If you're of the mindset and you are qualified and trained and you have the instrumentation, and the instrumentation's correct and the airplane's set up for it, and you have gaming injectors in your Lycoming engine, and you are operating at the just bleeding edge of efficiency in a Mirage, because that's really where you want to be, then so be it. Realistically, that person will be safe and the engine will probably be fine because they have studied it and they understand it. The aircraft is instrumented for it and it has the equipment installed on it to make it efficient enough for it to be feasible. But that's not every Lycoming, and that is by no means every owner.
That's exactly right.
And that's where I'm going with that is, if you are that type of person, then by all means do it. It is not recommended because it's a lot more pilot workload for it to work out right, and you're giving up a lot of airspeed benefit for fuel savings and temperature benefit. So, and if done wrong, if you end up with someone inexperienced or is not well practiced in lean of peak or in an aircraft that is not instrumented for it, that bleeding edge can definitely be bleeding because you can operate the engine just enough out of lean of peak or just enough into the rich zone that you end up with detonation and you catastrophically destroy the engine in flight.
That's right. You can end up with a cylinder or two in the red zone, meaning that they're not lean to peak. 4 of the 6 are, and 2 are not. And those 2, you can fry those things.
Right.
And you end up with detonation. It can be and now we got people that are going 34 inches of manifold pressure. I mean, this engine's just not designed for this.
Yeah, standing on it.
It's just not. I will tell you, if you are passionate about lean to peak, and that's what you want to do, and you want to put the gamma injectors, you want to do everything, you want to sit there, put the instrumentation, do it. I'm all for it. I love lean to peak. Don't let anybody hear me say I'm against lean to peak. I love it. For the right engine, for the right installation. I will tell you, there's one place that Mirage and Matrix pilots never do or rarely do, don't understand, but it's a wonderful power setting, and that is to simply pull the power back. So instead of running at 30 inches of manifold pressure, 2,400 RPM, and then 22 gallons an hour, you can pull the manifold pressure back to 26.5 or 27, and then pull the mixture back to peak, not lean of peak, peak. And this is exactly in accordance with the POH. The POH tells you exactly how to do it. The problem is you got to pull the power back. And when you pull the power back, now you're going to slow down, say 15 knots, but now you're going to be burning, if you're at 26 and a half or 27 at peak, you're probably running 16 and a half or 17 gallons an hour. You'll be below 1600 TIT, and this engine will last a long time. Matter of fact, I love this. You're going to slow down from what you were doing. You're not going to do 200 knots at 20,000 feet. Probably going to do 185, I'm guessing, 185 or so. But what this allows, it does 2 things. Number one, you slow down, which you don't want, but your fuel flow goes way down. Your range goes way up. So if you need to make a destination, like let's say you want to fly 5 people and you have to pull your fuel off the airplane. Well, now you could probably make that destination if you'll just fly the airplane slower and go to 26 or 27 inches of manifold pressure, pull back to peak, be below 1600 TIT, and you can cruise there a long time. The other one is it's not an overly rich position, so you don't end up with clouded rings, and you get up with a really nice burn that happens. You don't, because all this extra fuel that we're dumping into a Lycoming engine ends up freezing rings and causing sludge and all the different things to occur. So it's not bad, but don't think you're going to run your Lycoming engine at 30 inches of manifold pressure, 2,400 back, and go back to peak, because you're going to be at 1,700 TIT, and your exhaust system is going to be, you're going to fry your exhaust system. It's within POH limits, but the POH it's too wide of
there's no margin left whenever you're in that configuration.
You're going to buy cylinders every 200 hours.
The whole point of rich a peak is it provides a very large safety margin in operation.
That's right.
It's a very big pillow. So that's the whole point. Once you get into lean of peak, your safety pillow is gone. So It is down to the operator.
I will tell you, I am. There's a guy that's not really in our community hardly anymore. His name is Chad Minnie. Chad used to own Malibu Aerospace and was just one of the best minds in our space. And he sold Malibu Aerospace and or sold his shares in it and went to the airlines. And I'll tell you, it's our loss in our community that Chad's gone. And Chad, if you're listening to this, we love you. But Chad had one of the best studies of the Lycoming engine and the ability to go to lean a peak and the ability to get the best performance out of this, because he wanted to have an engine where it was all FADEC. And he worked, he knew all the numbers inside and out. I've had long talks with Chad, And Chad is, I've benefited from those talks. But I'm going to get Chad on the Malibu Guru podcast one day. We're going to talk about a bunch of, there's probably going to be 2 podcasts, but one of the things we're going to talk about is running the Lycoming engine, lean a peak, run it rich a peak, and run if how the FADEC didn't work for him, how all that didn't happen. Finances got in the way and all kinds of stuff. Anyway, Chad's just one of those really interesting guys. And we're going to give a longer talk about lean a peak and rich a peak. But for now, if you do not have instrumentation in your airplane, in other words, you don't have the ability to look at the EGT for every cylinder in your Lycoming, don't run lean a peak.
Correct.
There's your answer. If you're like wondering, can I do this? Well, 90% of Lycomings don't have an EGT for every cylinder. You have to have a gauge that's installed on the airplane. Just don't do it. That's thing one. And thing two, if you really do want to do it, then install the right instrumentation and learn how and get gammy injectors and go forth and do great things. And you might be able to get yours to run lean a peak. If you are, great. You're one of those guys that say you're a diehard lean a peaker, and I'm all for you. I'm one of you. I love you. I think you're great, but it's just tough on a Lycoming.
It is.
Yeah, I think that's the answer. No instrumentation, no lean a peak, and if you really want to run your engine like lean a peak, it's just exactly like you're getting the same fuel burn, same performance, same everything. Pull your cruise performance back to 26.5 or 27, somewhere in that ballpark. Pull back to peak. Make sure that peak is below 1600. That's my personal Joeism, to not run your TIT above 1600. That's a Joeism. It's not written anywhere, but you want to buy a whole bunch of expensive exhaust parts.
Your turbos will thank you.
Yeah, your turbos will love you if you keep your TIT below 1600. And that's how you make this engine last a long time and do great things. Pull your power back to 26.5 or 27 and run it at peak. Keep your TIT below 1600. That you can run that Lycoming way off into TBO and you'll have a great thing. I will tell you, hardly anybody does it. And the reason why is everybody bought the airplane to go fast.
Yep. And nobody likes giving up speed. It's always a trade-off.
And if that just totally pisses you off, go buy a Continental and go lean a peak because it's designed for it. And it'll be a good thing. That's for sure. Yeah. Kenneth Hale, thanks a bunch. Appreciate it. Director of Maintenance for Casey Aviation Services. General good guy in this community and the spearhead for lots of growth we're going to have in the near future in maintenance here at Lufkin at Casey Aviation. Appreciate you being a part of what we got going on the Malibu Guru Podcast and the Casey Aviation YouTube channel.
Thank you for having me.
Appreciate it.